Hi everyone, I'm Andrei Jarcă, master student in AI at the University of Bucharest. I'll showcase our work developed together with my co-authors, Florinela Lincroitoru and Professor Radu Tudor Ionescu on improving downstream performance through anti-curriculum by masking. Let's get started. Here's a quick roadmap for this presentation. I'll start by explaining the motivation behind our approach. Afterwards, I'll describe our method, our main experimental results, and finally, I'll conclude with key takeaways and future work. Now regarding the motivation. Random masking is common in language model pre-training but can limit downstream performance, and retraining full models is costly. We propose TICBM, a data-level anti-curriculum that increases training difficulty by masking tokens important to the downstream task, such as text categorization, authorship attribution, or sentiment analysis. The method is generalizable, and when combined with cycling the masking rate from high to low, it boosts performance and prevents catastrophic forgetting. Masking important words works by disrupting feature co-adaptation as dropout does. Alright, now let's walk you through the details of our method. We define a curriculum vector R with the cycle length k, where Rt is the masking ratio at iteration t and Rk is the maximum. The masking ratio decreases over each cycle following this schedule. The full procedure is summarized in the algorithm on the left. After setting the masking schedule, we move on to selecting which tokens to mask. For each input sentence, we compute an importance score S of I for each token X of I depending on the specific downstream task. We normalize the importance scores to obtain P of I, which represents the probability of masking a specific token. And finally, we sample tokens based on the computed probabilities using a categorical distribution over the input sequence. If a sample token is not a special token, we simply replace it with a masked token. So how do we compute the importance scores? For sentiment analysis, we use SentiWordNet 3.0 to estimate word objectivity, giving higher importance to tokens with stronger sentiment. For text categorization and authorship attribution, we average attention weights and assign them as importance scores. In text categorization, we prioritize content words like nouns and verbs, while other words are excluded from masking. For authorship attribution, we follow the same process, but we focus on functional words such as adpositions, conjunctions, and punctuations, which are more stylistic and relevant to the author's writing pattern. Now let's see TICBM in action. We used SST2, Reuters and 20 Newsgroup, and two PEN19 subsets, each selected for their relevance to the specific task. We applied our method on three architectures, BERT-based, Roberta-based, and to demonstrate that TICBM also works on large language models, we employed GPT-2. We fine-tuned BERT and Roberta, comparing our method against several baselines: a conventional approach, constant masking, cartography-based curriculum proposed by Poesina et al., linear decay proposed by Engner et al., and cycling decaying as an ablation without task information. Across all datasets and tasks, our method consistently achieved statistically significant improvements and outperformed all baselines, notably reaching the top 1 micro F1 score on Reuters. In a similar way, we obtained strong results on GPT-2, illustrating that TICBM generalizes across architectures. Here we compare traditional curriculum learning easy to hard to our anti-curriculum approach hard to easy, referred to as TICBM when reversed. As shown in the tables, hard to easy consistently outperforms easy to hard across all tasks and architectures. In this ablation, we applied the SST2 sentiment heuristic to PEN19 authorship attribution, comparing it to the original heuristic and conventional masking. On PEN problem 5, the sentiment heuristic outperforms the original, likely due to subjective fandom language. Both outperform conventional masking, showing TICBM's effectiveness even with misaligned heuristics. We also introduced a generic task-agnostic, attention-based heuristic using fine-tuned model attention scores. While task-specific heuristics perform better overall, the generic method excels in some areas and serves as a useful alternative when no task-specific priors are available. And to conclude the presentation, we've shown that designing task-informed curricula for language models improves performance on downstream tasks. We propose several directions for researchers to further investigate. Firstly, constructing adaptive schedules that can generalize regardless of model or task, and secondly, explore to what extent the proposed method also applies in language generation, translation, or much larger models in general. Thank you for watching our presentation. You can explore our public repository to learn more about the implementation of TICBM or refer to our paper for detailed explanations and ablation studies. If you have any questions, feel free to contact us at any time. We'd be happy to discuss further. We also invite you to visit our poster at ACL 2025 in Vienna. We look forward to seeing you there. Bye bye.